So what if I told you that a single algorithm, just a piece of code, could send a massive shockwave through the entire multi-trillion-dollar tech industry? Now, I'm not talking science fiction here. This is the real story of Google's TurboQuant, a breakthrough that's completely rewriting the rules for AI and all the hardware that powers it. And to really get how, we first need to talk about this huge, invisible problem that's been holding everything back.
So why is this such a big deal? Well, to understand it, we have to talk about a problem that anyone who uses large AI models has definitely felt, but almost nobody can actually name. It's called the GPU memory wall, and it is the invisible bottleneck that's slowing everything down.
And this image, well, it just lays it out perfectly. On one side of the scales, you've got the actual AI model itself, the model weights. But look at what's completely crushing the other side of the scale, this monster pile of temporary data called the KV cache. This cache, it stores the context of your conversation with an AI, and it is absolutely overwhelming the most expensive, most powerful GPUs on the entire planet. And the scale of this problem is just staggering. This KV cache can eat up 80 to 90% of a GPU's precious memory. What that means is your multi-thousand-dollar processor is literally just sitting around, twiddling its thumbs, waiting for data. For a big AI model that's trying to process a large document, we're talking about needing over 40 gigabytes of the world's most advanced memory just to keep the conversation going. So the key here is, this isn't some small inefficiency. It's a colossal, expensive waste.
But what if you could shrink that massive pile of data way, way down without losing any of the important information? Well, that is the exact question that Google set out to answer. And their solution? Enter TurboQuant, an incredibly elegant fix for this billion-dollar bottleneck.
So first, it makes that monster KV cache 6 times smaller, which in turn makes the entire process up to 8 times faster.
And here's the kicker, the part that honestly sounds impossible. It does all of this with zero, and I mean absolutely zero, loss in accuracy.
This slide just shows the whole thing in action. You've got this huge, clunky stream of 16-bit data going in one side, the TurboQuant engine works its magic in the middle, and out comes this super clean, hyper-efficient 3-bit stream of data. Smaller, faster, and just as smart.
So how on earth is this even possible? I know it feels like magic, but it's actually just some incredibly clever math. Let's take a look inside the engine.
Okay, the first step is what they call a geometric shift. Just look at the before image. It's a total mess, just a chaotic scatter of data points. But then, TurboQuant applies a random rotation, and suddenly, like you see in the after image, all that chaos is forced into a perfect, predictable circular pattern. By turning randomness into a predictable shape, the data becomes dramatically easier to compress. But that first stage, it isn't absolutely perfect. It leaves behind a tiny bit of mathematical error. Stage 2 cleans that up. This slide shows how it uses a really cool technique to transform that tiny leftover error into a single bit, just a +1 or -1. It's kind of like a 1-bit barcode that perfectly balances the scales, making sure the final result is mathematically unbiased and incredibly precise. Now, Google isn't the only one in this game. NVIDIA has its own approach, and it can actually achieve even more compression. But the core philosophies here are completely different. NVIDIA's method, it's like a custom-tailored suit. It requires complex, model-specific calibration to work right. TurboQuant, on the other hand, is built to be a universal, drop-in solution. Think of it like the perfect t-shirt. Zero setup, zero overhead, and absolutely no compromise on accuracy. It's designed to be used by everyone instantly. So you've got this amazing breakthrough that makes AI dramatically cheaper and way more efficient. That should be great news for everyone involved, right? Well, the market, let's just say it had a very different reaction.
And the logic seems pretty simple, doesn't it? If you can suddenly fit 6 times more data into the same amount of memory, surely that means you only need to buy 1/6 of the memory, right?
And that is the exact logic the market ran with. The day this research paper dropped, stocks from major memory manufacturers like SK Hynix and Micron just plummeted. The market totally panicked, thinking that this brilliant software breakthrough just made a whole lot of expensive hardware totally obsolete. But here's the thing. History proves that calculation is fundamentally wrong. The reason the market got it so wrong comes down to this really fascinating economic principle from the 19th century that, believe it or not, is more relevant today than ever before. It's called the Jevons Paradox. So, way back in the 1800s, an economist named William Stanley Jevons noticed something weird. When steam engines got more efficient, Britain didn't use less coal. No, they used vastly more coal. Why? Because the efficient engines made coal power so cheap and useful that it unlocked thousands of new applications they'd never thought of before. The paradox is, efficiency doesn't decrease consumption, it ignites it.
And this is the exact same flywheel we're seeing with AI today. TurboQuant's algorithmic efficiency makes using AI cheaper. That big drop in cost leads to an explosion of new use cases, all the stuff that was way too expensive or impractical to do before. This creates new demands, like being able to process massive documents, which in turn drives even higher demand for the hardware underneath it all. See, cheaper AI doesn't mean we'll buy fewer GPUs, it means we are going to put AI into absolutely everything.
So, what does this new era actually look like? Well, the real impact here goes way beyond just making cloud data centers a little more efficient.
The true game changer here is unlocking what's being called sovereign intelligence. And what that's about is moving massive, powerful AI models out of those centralized data centers and putting them onto our own local hardware, our workstations, our laptops, maybe even our phones one day. It's about giving all of us, individuals and organizations, the power of large-scale AI, but privately and securely.
So, the big takeaway for you here is that the entire landscape is about to change. Analyzing entire books or huge code bases in one go, that's going to become a standard feature, not some premium luxury. And a giant AI model that once required an $80,000 server rack, soon it could be running privately on hardware that you own. This is the real algorithmic shockwave.
Which leaves us with one final and I think really fascinating question.
This breakthrough isn't just about making the AI we have today a little bit better. It's about unleashing a completely new class of accessible, personal, and powerful intelligence. So, when that power is truly everywhere, what happens next?